Our next speaker is Mr. Khasim. He'll be giving a different take on AOSP. It'll be interesting to hear.
Okay. Hello, everyone. Good afternoon. I think we are almost like near lunchtime, so I'll try to cover very few slides so that it keeps you engaged. And the topic that I have taken is mainly to show how we can take some kind of a fresh look on Android ASP's role in embedded systems. So the area that I want to take is like taking Android beyond mobile, beyond uh, TVs and automotive, right? I work at Texas Instruments, and have been using Android AOSP project for quite a few years now. Starting, I heard Android 12 and 13, but when I started on Android, it was like Android B, like butterscotch and cupcake and donut. So I started using Android back in 2008 9 time frame. So have been involved in Android projects for a long time now. And my area of interest always has been to use Android for non-mobile, like wherever Android and Google generally prefers using Android for their own concepts, and like especially mobile and TVs and automotive. I have always tried to use Android for non Google's projects. So, and I have been very successful in that, because Android is the one good part of Android is it's completely open source projects, and AOSP has definitely been very useful for this prototyping of Android for non-mobile applications. So, just to give an historical overview, like as I am showing on my slide as well. So, have been using Android since 2008, and built as part of TI, and as well I have seen many customers using Android for non-mobile application spaces wherever there is an UI entity, right? If you want to have some very good jazzy UI, and I have seen customers building products using AOSP project, be it medical applications, like where you have UI for medical applications, industrial HMI, big kiosk, and today we are seeing like kiosk used in EV charging stations and many such places, right? There are many end applications like consumer appliances and things like that. Wherever you see a UI based device, Android is the first best fit that goes there. And also connected applications, wherever you have some devices which needs to connect to internet of things, or in any internet application. So Android has seen, AOSP projects generally has seen benefits there. So the key advantages in these areas, mainly it is very portable, UI advantage, and Linux based software stack. So anything that you need to customize or optimize, you can do in Linux, and that gets carried over into Android distribution, right? So or Android application layers. So these things have definitely made Android AOSP project a scale into non-mobile and non-AOSP, and non-mobile and to non-TVs and non-automotive segments. And this is historical thing, right? So today, I just want to show one quick video here. Before we video, I just want to show. So this is a screen. I'll tell you what exactly the screen is about. But this have a video of an embedded system where this screen is being shown. Like you can just see like the kind of skins that it is showing, the movement of multi-touch connectivity, connecting to sensor, different types of sensors, connecting to cloud, or connecting to network applications, right? And this is one. And I also have a video. Let me see if I can. Yeah. So this is an analytics. So you can see like it plays. So there is an audio classification model running, and that basically says now this is a police car siren here, right? So I just showed you historically what has been done in Android, and I just shared with you an embedded system of current day. And the device that I showed in my video there is an embedded system which is running ARM Cortex A53 dual core, no GPU, no AI accelerators or no NPU inside, and no audio acceleration, nothing. It is a bare metal dual core Cortex A53. So it is TI's latest generation AM6, like AM62 series of device, AM62L we call. Okay, so it is a very light version of an microprocessor just running bare metal Linux. So embedded systems has evolved to a place where a simple microprocessor, or I mean to say Linux, has evolved to a place with all its other distributions. The skin that I showed is an LVGL graphics stack, which is giving you the UI screen. And there is an audio analytics which is running on just Yocto based distribution, which is giving audio classification and audio models which can easily classify what type of audio is getting played and things like that. So um, the current generation of Linux plus Linux distros, be it Yocto or Debian or Buildroot or any such distros, are giving the flexibility that an end equipment needs for building any kind of UI or bare minimum analytics, or analytics over the edge, or edge AI, whatever you call, right? So today embedded systems are able to get the power of Linux and Linux distributions and scale to the needs of end consumer without using Android, right? So earlier, in order to get to that level of UI and analytics, we were supposed to go to Android, and Android phones and Android tablets were giving you that kind of UI richness. But today, even with just bare metal build root kind of an distribution, you can get to that level of UI experience. So then, is it an advantage to even consider going AOSP route to build that kind of richness for embedded systems or embedded equipments which are non-mobile or non-TV or non-auto? Definitely, there is lot more room and advantages that one could get by going to AOSP. I already showed in my previous video where embedded systems with Linux and distros are already scaling to the richness of Android UI, but still by using AOSP for embedded equipments, you can definitely get a lot more, right? Android is also evolving on other side, but the only caveat there is Android needs GPU, Android needs high end accelerators, Android needs multi core processors for doing its processing, but that is on the hardware side of it. But the kind of flexibility it offers for an end equipment is still vast and wide, right? So, some of the key factors that I have listed here, even for user interface, right? Full featured UI toolkit that is available on Android, you won't get in any kind of Linux distributions that we have in the market today. The kind of device ecosystem that we have, or the app development ecosystem that we have for Android, you won't find it very easily when you migrate to embedded space, like be it Qt or be it an LVGL, or the developers that we have today in the industry today are very limited for these kind of UI toolkits. And the kind of time to market that you can build by going to AOSP and Android is very fast, very quick, right? Like you pick any off the shelf tab or off the shelf mobile, you can start quickly prototyping your end use case or end application. Same thing to do with for an embedded equipment becomes too complex, and these are some of the areas where Android AOSP still stands out for building any kind of an embedded equipment with AOSP project. So, what are the end equipments and opportunities that we are talking here for using or leveraging AOSP? Like as I said, majority of your mobiles are Android today, and then TVs for smart TVs and automotive infotainment, and these things are Android today. Apart from that, when it comes to very core real time operating system requirement or real time needs, like if you see the graph that I am showing, if your embedded equipment needs a very real time processing, that is not the area where you would want to use Android, right? And if your UI needs are very minimal, that is not the area where you would prefer Android usage, right? So the green color area that I have shown here, where your UI richness is high, your connectivity requirements are high, and your real time determinism is low, in such segments you can definitely start using AOSP projects. So some of the key examples are like consumer appliances, medical end equipments with UI, and industrial HMI and infotainment systems. So all these segments will cater to this AOSP usage. So then what in AOSP, like is AOSP best suitable or direct fit for building embedded end equipment? Like if you see in those lines, I would say there needs to be more simplified versions of AOSP to fit into an embedded equipment, right? Today, when I talk to my customers who are building their end equipments, they even find Linux subsystems very hard, right? Like they think Yocto is very difficult for them to understand. Building Debian distribution based end equipments are very difficult for them to understand. They are coming from microcontroller to Linux, or Linux to a distro based Linux and things like this. So for them all these things are way too complicated, who are so used to real time environment. So for them we have to make Android AOSP very easy, very thin and lean, very good recipes to build, like PLCs or your embedded HMI, or you are building a simple UI based solution. So there should be ready made populated what do you say, stacks, which because these end equipment manufacturers can use and go into production. So it should be completely hand cooked devices. Like if we can build that kind of distros, it will definitely enable usage of AOSP into non-mobile applications. So there are tons of infrastructure projects, open source stacks and tools and everything which is available in AOSP, which will definitely benefit a lot of end equipments, right? And AIML is one part, development tools, then the complete CVE management and long-term maintenance, OTFA, all these things are way too what do you say, way too important concepts that can be leveraged from AOSP for building end equipments on embedded systems. So this is what I had to say here, and before I end my session, I just want to announce this new Beagle Y AI platform, which is on TI's AM67 processor, which has GPU and which has AI accelerators, and it has multi-core A53 ARM core running. And if you are interested in building any kind of end equipment solutions on these platforms, so and if you want to join us in building Android for AOSP projects and making AOSP projects better for embedded systems, then feel free to reach out to me. We are definitely willing to collaborate with you in an open source way. Reach out to me and I can definitely ship you a Beagle Y AI hardware platform to do this Android open source software development. So I'll stop here, and feel free to reach out to me later after this session, and we can definitely discuss on how to enable embedded systems with AOSP. Thank you.
Do we have any questions? Thank you very much, Khasim sir.